$128 billion, 350 kilometers per hour, 800 tons of steel and kinetic fury, hovering over the most violent geological tear on the planet, the San Andreas Fault. This is not just a megaproject. It is a declaration of war against the Earth's crust. Welcome to the California high-speed rail. Look at the horizon. Concrete pillars slice the setting sun. Golden light bleeds onto cracked desert soil. Heavy machinery casts long, ominous shadows. A massive gamble. Floating thousands of tons of engineered infrastructure on a tectonic time bomb. One slip, one miscalculation in the deep foundation. The ground rips open. Tectonic shear violently forces the structure apart. Concrete shatters like brittle glass. How do you build a monolithic structure that survives absolute tectonic execution? Two megacities, Los Angeles, San Francisco, 800 kilometers apart. The mission: connect them, decimate travel times. The obstacle: pure geographical brutality. The Central Valley: scorching 50 degrees Celsius heat. Choking dust storms, ground baking solid under the relentless sun. The true enemy hides below. The tectonic boundary. Two continental plates locked in a death grip, grinding, building immense pressure, waiting to snap. Seismic shear forces. Nature's guillotine.
I stand here in the suffocating dust. The deafening roar of heavy diesel rigs shakes my boots.
The dirt looks calm. It is a lie. The ground beneath this valley is a loaded weapon. The fault fractures. It releases megatons of kinetic energy. Shockwaves rip through the bedrock at 5 kilometers per second. A standard bridge absorbs that energy. It snaps. Steel rebar stretches to ultimate failure. While concrete explodes under the violent shear strain. You cannot fight the earth. You cannot build columns thick enough to stop a moving tectonic plate. Force meets rigid mass. Rigid mass dies. The engineers knew the strict parameters. Standard structural logic meant catastrophic failure. Thousands of lives lost in a fraction of a second. They required a structure that slides, a bridge that actively evades the seismic shockwave, an impossible problem, demanding an unprecedented engineering anomaly. The human counterattack begins exactly 60 meters underground. Phase 1. Deep foundation excavation, 60 meters down. Massive 150-ton rotary drilling rigs dominate the valley floor. Steel tracks crush the dry earth. Diamond-tipped auger bits pierce the hardened geology, violently chewing through solid granite layers. For friction superheats the drill teeth, the deafening roar of twin 1,000-horsepower diesel engines, the smell of pulverized rock, the stench of burning diesel.
I lean over the steel casing. 60 meters of black vertical abyss.
A suffocating heat rises from the core. One misstep, a fatal, crushing drop into the earth. Massive crawler cranes swing into position, lowering 50-ton cylindrical steel reinforcement cages, thousands of thick rebar intersections, hand-tied by iron workers, engineered to resist immense seismic bending moments. High-pressure pump trucks arrive. 8,000 cubic meters of high-strength concrete pour, forcing out the dense drilling mud. The chemical reaction begins. The concrete cures, generating intense exothermic heat, solidifying into immovable monolithic roots, anchored deep in the crust. Massive structural pillars rise, for 30 meters into the scorching sky. Phase 2, the structural anomaly, friction-pendulum isolators, the critical mechanical joint, the only lifeline against total collapse. Standard bridge bearings rigidly lock the deck to the pillar. Earthquake hits. Rigid bearings shatter. The deck plummets. Isolators rewrite the physics. Massive concave stainless steel bowls, coated in industrial Teflon. An articulated central steel slider sits inside. The 3,000-ton concrete bridge deck rests entirely on these sliders. Tectonic plates snap. The ground heaves. The 30-meter concrete pillars whip violently side to side. The isolators engage. The massive deck slides gracefully across the concave dish. Total mechanical decoupling. Kinetic energy dissipates into harmless thermal friction. Gravity forces the heavy slider back to the dead center of the bowl. Self-centering, auto-stabilizing, complete isolation. Phase 3. The balanced cantilever viaduct. Crossing vast, uneven canyons. Zero ground support allowed. Massive 200-ton steel form travelers clamp onto the top of the bridge piers, pouring concrete segments outward into the void. Left side, right side. Perfect symmetry, balancing thousands of tons of wet mass in thin air. Gravity pulls down relentlessly. Wet concrete possesses zero tensile strength. It wants to snap. It wants to fall. The countermeasure, post-tensioned cables, hundreds of high-tensile steel tendons, threaded through hollow PVC ducts inside the concrete box girders. Massive hydraulic jacks clamp onto the exposed tendon ends, pumping hydraulic fluid, violently pulling the steel strands with 8,000 kilonewtons of shear force. Stretching the thick metal like rubber, heavy steel wedges slam into place, locking the extreme tension. The tight cables compress the concrete segments together, squeezing the internal molecules, forging an artificial diamond-like hardness. You stand inside the dark, hollow concrete box girder. 8,000 kilonewtons of tension surround your body. The sheer pressure makes the concrete groan. One defective steel wedge. The tendon snaps back like a titanium whip. Decapitation is instantaneous. No warning. Day by day. Pore by pore. The massive cantilever arms reach toward each other. The gap closes. Total engineering dominance over the valley. A flawless mathematical design, completely meaningless against unpredictable geological betrayal. Sector 4. The open desert plain. Routine pile excavation. Disaster strikes without a single warning. A localized sinkhole opens deep underground. An ancient subterranean void, undetected by ground-penetrating radar. The heavy 150-ton rotary rig tilts suddenly. A freshly poured, massive foundation pile shifts in the dirt, just 40 millimeters off axis. A fatal, project-killing deviation. The entire balanced cantilever structure above relies on absolute millimeter precision. 40 millimeters translates to catastrophic structural misalignment at the central span connection. The massive cantilever arms will miss each other in mid-air. The $128 billion timeline halts instantly. I climb down into the excavated foundation trench. The midday heat is suffocating. The massive concrete pile leans ominously. You can hear the earth physically groaning. The soil is actively collapsing around the concrete base. We are losing the foundation. Extracting the cured pile is physically impossible. Abandoning the site costs tens of millions. The lead engineers initiate a brutal emergency stabilization protocol. High-pressure epoxy grout injection. Heavy rigs drill rapid microshafts around the sinking pile, inserting perforated steel injection tubes deep into the collapsing void. Massive industrial diesel pumps roar to life in the dead of night, forcing synthetic chemical epoxy into the unstable geology. 15,000 kilopascals of relentless pressure, violently injecting the liquid compound into every microscopic soil fracture. The epoxy violently expands, binding the loose, shifting desert sand into a solid synthetic rock matrix. Working totally blind, trusting only the analog pressure gauges. Hours pass in high-tension silence. The sinking completely stops. The deep foundation stabilizes. The 40 millimeter deviation remains permanently. The top cantilever geometry must be radically recalculated, adjusting massive formworks to close the misaligned gap, a permanent, invisible scar on the perfect mathematical design. Look away from the massive steel machines. Look at the flesh. Look at the blood. The Central Valley sun acts as a relentless blowtorch, 50 degrees Celsius ambient temperature. Inside the hollow concrete box, girders, the temperature spikes. 60 degrees, a brutal, suffocating industrial oven, 10,000 workers, relentless 24-hour shift rotations, no stops, no pauses. The schedule demands absolute compliance. The sharp, toxic smell of vaporized welding flux fills the air. Thick, abrasive silica dust coats every surface. Lungs burn. Eyes sting constantly. You stand on a vibrating steel grating, or 30 meters above the baked earth. Searing crosswinds blast your face. A towering crane swings a 50-ton precast concrete segment inches from your chest. Heavy steel cables groan under the immense load. One frayed wire. One singular moment of physical fatigue. Gravity instantly claims your life. Zero margin for error. 0 second chances. Survival demands hyperfocus. Iron workers wrestle heavy steel rebar matrices. Leather gloves practically melt against the scorched metal. Surveyors battle intense optical heat mirages, calculating complex laser alignments down to the final millimeter. Megaprojects always demand a heavy physical toll. Safety protocols remain absolutely merciless. Strict compliance, total discipline. Every single square meter of this $128 billion empire requires human sacrifice, sweat, exhaustion, pure physical endurance. Heavy machines execute the brute force lifting. Human sheer will forces the raw elements into absolute structural submission. The golden hour approaches. Shadows lengthen violently across the valley floor. Hundreds of miles of monolithic concrete pillars divide the barren landscape. A continuous, unbroken ribbon of pure engineered perfection, suspended directly over the deadliest tectonic boundary on the planet. The ultimate cinematic vision finally materializes. An 800-ton aerodynamic projectile approaches the viaduct, 350 kilometers per hour, screaming over continuous, perfectly aligned welded steel rails, ripping through the heavy desert air, annihilating the vast geographical distance. Los Angeles, San Francisco. Deep below the massive concrete columns, the San Andreas fault sleeps, building immense tectonic pressure, storing unfathomable kinetic energy, preparing for the inevitable violent rupture. The massive Friction-Pendulum isolators stand ready in the dark, waiting for the catastrophic strike. $128 billion. The ultimate structural insurance policy against total geological annihilation. California's high-speed rail is not merely a transit system. It remains a brutal monument to human defiance. We refuse to bow to nature. We engineer directly over the ultimate threat.
The horizon belongs entirely to the builders. What impossible mega project should we bring to life next? Tell me below in the comments.
Tell me below in the comments. Hit subscribe. Join the elite structural vanguard. Never surrender to the elements.